Hello everyone, my name is Mohammad Reza Moini, and in this video I want to talk about non-deterministic simulation. So, in deterministic simulation, what we usually do is, this is what we do. So, we have our simulation, this is our simulation for instance, and we know our inputs. We know all the input parameters. So for instance, we know the geometry, we know the material properties, we know the boundary conditions, we know the initial conditions, and we know all the inputs. And based on these inputs, and based on our simulation and the mathematical model that we have, we solve a finite element model or we solve a finite difference model, and then we compute the output. The output might be the displacement field, the strain field, and or the stress or the reaction force or velocity or acceleration or any kind of output that we want to compute. So this is our deterministic simulation. In deterministic simulation, we solve the equations one time. In non-deterministic simulation, for instance, we don't know the exact material properties. So for instance, we don't know exactly the Young's modulus or the Poisson ratio, or we don't know exactly the geometry or boundary conditions or initial conditions. So what we do here is that we solve our simulation, and instead of one time, we solve it 1,000 times. And instead of one single output, we will have 1,000 outputs. So we compute an average and a standard deviation of the output. So we have this set of solutions. For instance, consider a mass spring damper system like this. This is our system, and our governing equation, our equations, our mathematical model is mx double dot plus cx dot plus kx is equal to F, which is the excitation force as a function of time. This is our equation, and we want to solve this equation. We know the spring coefficient is K, we know the damper coefficient is C, but we don't know exactly the mass here. We go to the factory and we are measuring this mass. We are measuring that, and we know that we have kind of porosity inside the material. So for instance, it should be 1 kilogram, but it is not precisely 1 kilogram, and we are measuring 1,000 mass, 1,000 mass, like M1, M2, up to M1000, and we are seeing that if we plot this mass with respect to the if we plot the number of mass with respect to our measurement, we see that for 1 kilogram we have maximum value, and for other value we have a Gaussian distribution with the average value of 1 kilogram and a standard deviation, I don't know, with 0.5 kilogram. So for 1,000 mass, for M1 to M1000, we can solve our system, and instead of one solution, so imagine that this is the solution of 1 kilogram, so this is 1 kilogram, and this is the displacement of x with respect to time. This is one response, and then we plot the other one. This is for 0.9, and or we can have another solution for 1.5 0.1, and so we solve our solution 1000 times like this, and then we can see that we have a set of solution with the average value and a standard deviation. So we have this group of solution. This is our solution for non-deterministic simulation. So this was a very short introduction of non-deterministic simulation. In the next video, I will explain more about that. Thank you for watching.